So if you are to solve for the centroid of one of these basic shapes right here, it is just a matter of direct substitution. So for example, that you only want to get the centroid of a rectangle, just substitute your base and your depth in these formulas right here. And if you want to get the centroid of a certain quarter circle, just substitute your radius in these formulas right here. But what if we are to deal with compound shapes? So as for compound shapes, so this would be the shapes that is the combination of two or more basic shapes. So what you're actually seeing here on your left is one example of a compound shape. So once again, how can we solve for that? What we would be doing here is that we would be dividing this into distinguishable shapes. So it would be up to you on how you would be dividing this. And in my case, I would just be drawing a line here. And as you can see already, we already have a triangle here. So let's say that this is to be triangle 1, triangle 2, triangle 3. What we would be doing for us to solve for the centroid of this shaded area right here is to get the moment about, is to get the moment of the area about a certain point. So if we want to get the centroid in reference to this line right here, so let's say that this, if this is to be the centroid, this is to be bar x, and let's say that this is to be bar y. So I'm not quite sure where the location of the centroid is. So for example, this is to be bar y. What we would be doing once again is to get the moment about this point right here. So moment of the area. Okay, so for the area of triangle 1, that is to be equal to, so if this is to be 12, so its dimension is to be 6 by 12. So triangle 1 is 6 by 12. So that is to be 6 times 12 divided by 2. 1/2 base times height. So that is to be the area of a triangle. So 6 times 12 divided by 2 is equal to 36. So that is to be 36 square inches. So let's pretend that this is to be in inches since they are to be unitless. So let's say that that is to be square inches. And for area 2, or the area of the second triangle, so if that is to be 6 inches, and this is also to be in 6 inches, so that is to be 1/2 6 times 6. So 6 times 6 divided by 2. And this is to be, so 6 times 6 divided by 2, that is to be 36. That is to be 18 square inches. And for our area 3, so for A3, that is to be equal to, so they both have the same area as with triangle 2, which is 6 times 6 divided by 2. And that would give us an answer of 18 square inches. What we would be doing next is that we would be getting the lever arms. And the lever arms would be in reference to this point right here up to their respective centroids. So I would just be shading this figure right here for you to see it clearly, since I myself can't see clearly because of the pattern. So I have now shaded our figure right here because of the pattern. Because of the confusion as brought about by the pattern a while back. Once again, for this shape right here, for this red one right here, if this is to be x1, so let's say that this is to be x1, that is equal to 12 divided by 3. So 12 divided by 3 once again is equal to 4. And this dimension right here, so if this dimension right here is half of 12, so that is to be 6. So if that is to be 6, 6 divided by 3, that is to be 2. And for this triangle right here, since its dimension would be 6 by 6, so that is to be 6 divided by 3, that is to be 2 by 2. And as for this, since they are, both of these triangles in the bottom are, have the same dimensions, this is also 2 and 2. Okay, so what we would be doing next is that we would be solving for the moment of the area about this axis right here. So it would be, let's say this is to be the x-axis, and this is to be the y-axis. So y, and this is to be x. So for us to get bar x, which is the location of the centroid of this composite member, we would be getting the moment of all of these areas right here in reference to their centroid. So if the centroid of A2 would be here, if the centroid of A1 would be here, so meaning our x1 is equal to 4. So this is to be x1. So for us to know the location of the centroid of this compound shape right here along the x-axis, we would now be getting the moment about this point right here, which is the origin. In area 1, this area of the triangle right here times the lever arm, and the lever arm would be x sub 1. So x sub 1, so plus area 2 times x sub 2 plus area 3 times x sub 3. And this should be equal to the total area. So area total times x bar. So this x bar right here is the location of the centroid along the x-axis. The location of the centroid of this compound shape, compound section along the x-axis. Okay, so note here for area total. So the total area is the summation of all the areas. So that is to be 36 plus 18 plus 18. So that is to be 72 square inches. Okay, so for area 1, that is to be 36 inches squared times x1. So what would be the value of x1? So the value of x1 would be the distance from this point right here. So from this axis right here to the centroid along the x-axis. So that is to be 4 inches. So 4 inches. So plus area 2, and our area 2 is equal to 18 square inches. And our x2 right here is equal to 2. So 2 inches. So plus area 3, which is also 18, times what would be the lever arm. So the lever arm right now would be the distance from this point to the center of this triangle right here, which is this. And since from end to end, that is to be 12 inches, so this is to be 12 inches minus 2 inches, because this is 2 inches. So once again, our lever arm here should only be this distance right here up until this point right here. Okay, so this is to be equal to 72 inches squared bar x. So solving for bar x, that is to be equal to, so I would just be putting them in the calculator to your left. So that is to be 36 times 4 plus 18 times 2 plus 18 times 12 minus 2. So 12 minus 2 divided by area total, so 72, and that would give us an answer of 5 inches. So the location of your centroid along the x component, the x-axis, is to be 5 inches. So drawing it here, its location would be somewhere here. So since you already know what the value of bar x is, let's now solve for the value of bar y. Okay, so I would now be erasing this. And for bar y, we would be using the same procedure wherein we would be getting the moment of all the areas, but this time about this axis right here. So once again, that is to be a1y1 plus a2y2 plus a3y3. So this is to be equal to the total area times y bar. So using this formula right here, substituting known values, that is to be 36 square inches times what would be y1. So for y1, it should be this distance from here up to your centroid. So for us to solve for that, that should be equal to, so 6 plus 2. So plus 2. So once again, it should be the location from this axis right here up to the centroid of that figure that you are analyzing. Okay, so that is to be that. And as for area 2, so plus, so area 2, if this is to be 2 inches, wait, I would just be deleting this. So if this right here is to be 2 inches and this is to be 6 inches, so 6 minus 2 to get this part right here. So this part right here. Or better yet, that is to be 2/3 times 6. But since we already know this value right here, which is 2, so 6 minus 2. Okay, so area 2, that is to be 18 times, 18 square inches times 6 minus 2. So 6 minus 2. And for the third one, so A3, that is also 18 square inches times the lever arm, and our lever arm here would also be 6 minus 2, which is this part right here. So this one. So 6 minus 2. So this is to be 6 minus 2. So using that, 6 minus 2, and so equals 80, and our total area is to be 72 square inches bar y. So times bar y. So solving for bar y, so looking once again to the calculator to your left, that is to be 36 times 8 plus 18 times 4 plus 18 times 4 divided by 72. Equal sign. So from that, our bar y is equal to 6. So 6 inches. So now that we have both bar x and bar y already, we could now locate the centroid of this compound shape, which has a dimension of 5 by 6. So I would just be erasing all of this for us to locate the centroid right here, which is 5 by 6. So I would just be summarizing it here. So centroid. So that is to be 5, 6. So meaning along the x-axis, that should be 5. So it should be 5. So it would be somewhere here. So that is to be 5. And for 6, for your y, this is to be 6. 1. So it would be here. So the location of your centroid is exactly in this point right here. This is to be 5, 6. So this is only one method on how you would be solving for the centroid of a compound shape. Another way is that you can solve it like this. So once again, your centroid here is 5, 6. Instead of dividing this into 3 triangles, meron pa tayong isang way actually. So if you have divided it this way, yung ginawa kasi natin kanina is that we have divided this into 3 triangles, right? But you can actually divide it like this in such a way that you can now have a triangle there. So meron kang triangle sa taas, then you would be having a certain rectangle here. Then let's say that this is to be A2. Kunwari A2 yung etong rectangle na to, and this is to be A1. And let's say that you would be having a certain triangle here na A3. So let's pretend that that is to be A3. And for example, that is to be the case, so dito sa A, by the way, this is A1. So for your A1, it would still be the same, 36 inches squared. But for your A2, since you would be solving it as a whole, as this whole right here, as this whole rectangle right here, that is to be 6 by 12. So 6 by 12 is equal to 72. So pwedeng ito 72 siya. And as for A3, So for your A3, instead of the method that I have shown to you a while ago, so etong A3 na to is to be 6 plus 6, which is 12 times 6 divided by 2. So yun yung area netong area na to. This area right here. So for you to solve for that area, that is to be 6 times 12 divided by 2. That is to be 36. So 36 square inches din to. By the way, 6 by 12 divided by 2. So this is to be 36 inches squared. But since you would be removing this part right here in solving for the total area, so our area total now is equal to area 1 plus area 2 minus area 3. And this should also be equal to 72, just like our area total a while ago. So 36 plus 72 minus 36. So confirmed, we have a total area of 72. And for us to get this, the centroid of this, so for bar x, so for bar x muna tayo, no? Bar x times area total is equal to area 1. So area 1 x1 plus area 2 x2, which is the area of this whole rectangle right here, plus the centroid of that rectangle. Then we would be subtracting this triangle right here. So minus a3 times x3. Or better yet, it is better for you to just make this a negative value. So plus a3. And ang a3 natin is negative, so plus negative 36 yan times yung lever arm natin, which is x sub 3. So yan, plus pa rin yan. It's just that your value for your a3 is to be negative. And for your bar y, so bar y at is equal to a1 x1. So a1 natin is 36 times x1. Then yung a2 natin is to be 72. Oops, by the way, y1 pala dapat yon. So y1, then 72 y2, then plus negative 36 y sub 3. And solving for these equations right here, you should also have an answer of 5, 6. So that is another way of solving of solving the centroid of your compound shape.